Hi, welcome back to Newton Chemistry. This is going to be Titration Problems Lesson 1A. Okay, so what we're looking at here is we're looking at if it takes 54 milliliters of a 0.1 molar sodium hydroxide to neutralize 150 milliliters of a HF, hydrofluoric acid. Okay. What is the concentration of the HF? All right, so let's look at the equation first for titration. Be M1 V1 equals M2 V2. So we're going to need to know what each one of these mean. So we're going to go ahead and do that real quickly. And we're going to identify everything. So our first molarity is 0.1. All right. Our amount is 54 milliliters. Our second molarity, we have no idea. And we have our 150 milliliters of our HF. Okay, so what we're going to do is we're going to isolate for M2. So M2 equals M1 V1 over V2. So we're going to go ahead and put in our values. Okay, so I'm putting some of my values in now. Let's see here. So we're going to get, let's see here. Is that there? We're going to get, of course, M1, 0.1, times our V1, which is 54 milliliters. That's molarity there, of course, divided by 150 milliliters. So milliliters cancel out. So let me plug this into my calculator and see what I get. Okay, so we're going to look at this. We're going to go, okay, see here, 0.1 times 54 divided by 150, and we get 3.6 times 10 to the negative 2 for molarity. You know, we could actually take pH and see what kind of pH this is. So let's do that. pH equals the negative log of our hydrogen ion, or sometimes we call the hydronium ion. We go pH equals negative log of 3.6 times 10 to the negative 2 m. Our pH is equal to, so we'll go here, let's figure this out here. We go negative log 3.6 exponential negative 2. And we get a pH of 1.44. And that makes sense because this is HF, and HF is an acid. And since it is less than 7, this answer right here does make sense. Okay, let's look at the second problem. The second problem is if it takes 30 milliliters of a 0.15 molarity phosphoric acid to neutralize 500 milliliters of potassium hydroxide basic solution, what is the concentration of the KOH? Okay, again, we go M1 V1 equals M2 V2. So we go M1 V1 M2 V2. So our first molarity is 0.15. Our first volume was 30 milliliters. Our second volume is 500 milliliters. Okay, and we want to know what the molarity would have to be. Okay, so let's set this up. We're going to isolate again in this case for M2. So M2 equals M1 V1 over V2. And again, I'm sorry that that 2 doesn't look that great, so we're going to fix that too. All right, there we go, that looks better. So M2 equals 0.15 molarity times our first volume, which was 30 milliliters, divided by our second volume, which was 500 milliliters. So they cancel out. And we get 10 point, is it 10? No, sorry, it's 0.15. 0.15 times 30 and divide that by 500. And that gives me a molarity of 9.0 times 10 to the negative third m. Again, I could check the pH on this. And let's see what we get here. This is KOH, right? Let's see here. So we're going to go POH equals negative log of 9.0 times 10 to the negative third m. So POH is equal to, let's see here, negative log 9.0 exponential minus 3 equals 2.0. All right, so now we're going to go and do pH plus POH equals 14 because we're using the POH. So the pH equals, sorry, not equals, but pH plus 2.0 equals 14.0. So pH is equal to 14.0 minus 2.0. The pH is going to equal 12. And that makes sense because KOH is a base. So this makes a lot of sense. So that's it for this lesson, guys. You have an awesome, snarly day, and we'll see you back here at Moose in Chemistry.